Hey y'all, how's it going? Welcome to a new video. Today we're going to talk about a subject I find very interesting, which is eloquent models, or rather active record models as data bags. For us to talk about this, let's first understand or just recap how active record models work. With the active record pattern, your model is basically a proxy for a database table. So if you have an e-commerce application and you have an order model, you probably also have an orders table where you have a table with a different name that's going to map into that model. If you have an order item model, you're also going to have an order items table and so on and so forth. With that said, the columns of these tables are going to be exposed in the model as properties. So if you have a total in cents column, that's going to be available in the model as total in cents. Essentially, your model is a one-to-one copy of your table columns. That's really good, especially when you're starting an application, because it allows you to develop features really, really fast. But on the long run, that also can be problematic because although your database structure, your database schema might look like one thing, that doesn't necessarily translate into what's best on your domain layer, on your application code. Sometimes you're going to have columns that can be exposed as on your domain models. That's fine. But more often than not, you're going to have situations where your persistence details should not be leaked on your domain model. So on this video, what I want to show you is a few options, some things that you can do, to have richer domains. And we're going to approach this from two perspectives. We're going to see it from a read perspective. It's common when you have active record models to treat all of your properties as primitives. So you're going to have integers, you're going to have arrays, you're going to have floats and all of that. But sometimes you want to express something a little bit richer. So you want to use richer objects on your models. That is maybe a value object, maybe a more complex object, and so on and so forth. And we're also going to take a look at this from a write perspective. A common anti-pattern, I would say, that happens very often with active record is, since you have this model that exposes all of the columns in the database, and it can also persist itself at any point in time, any place in your code, it's easy for you to just start filling attributes in your models in any place in the application. And if you treat your models as data bags, then you're doing it all over the place and you don't have an authoritative representation of the operations your model supports. Let's go into the code editor and look at some examples. All right, so I have a very simple project. We have orders, we have order lines. I set up some stuff already. And if we look at the database structure, we have a couple of interesting things. We have a status column. We have a total in minor column. That is, if we're talking about, for example, the US dollar, this would be in cents. And we have the currency used for that order. So in typical active record, you could find an order, right? You could say, give me an order, for example. And now you have your data bag, if you will, if it is data bag. But you can access any of these properties. You can say total in minor, and you're going to get an integer. You can say currency, and you're going to get a string. Let's do a quick exercise. Let's imagine that active record doesn't exist. You have to write objects and hydrate them manually. How would you model that object? Well, I can say that status would definitely not be a string. I would say something like order status, and we already have one of those. And then total in cents or total in minor, that's really not what I'm interested in. This is a very simple example, so remember, extrapolate this to real life. You have far more complex models. But I would probably want a richer object that represents a monetary value, and that's coupled to a currency. I already wrote one, so we have a very simple money object. It takes an amount in cents, and it also takes a currency. So what I would really want here is not something like total in minor and then currency. That's not what I'm looking for. What I'm looking for is I would like to have a money object that says total. Additionally, an order is going to have order lines, and we're going to cover this in active record in a second. But an order line is something that does not work by itself. You cannot have an order line without an order, and you typically do not query order lines directly. You get an order, and the order lines are just part of it. So if I were not using an active record, I would just say that this is an array, let's say lines, and I would type this and say that it is an array of order lines, right? I could say something like this. So I'm saying that lines is going to be a collection of order lines. This is how I would model this object without active record. And then I would have some sort of repository that would hydrate this find by ID. And then you have ID, and it would return one of those orders. And then it would fetch this data from the database alongside any required items like the order lines. And then it would just spit out a new order object fully hydrated. With active record, some of this is possible and some isn't. Let's start about richer models, return richer objects as your properties. With Eloquent specifically, you can cast things. So I also have an order controller here, really simple, just so we can test some things. It just creates an order. We pass some products we want to purchase, and we get an order back. So let's take a look at this order object. Let's run this test. We have a status, we have total and minor, we have currency. With Eloquent, as you're probably aware, you can cast properties. So you can say that status is going to be an order status enum, and currency is going to be a currency enum. So this is pretty cool. If I look into status, you can see that we get an enum back. That's a richer object. That's not a primitive. If I look at currency, same thing. We get an enum back. The catch with active record is, and with Eloquent as well, and that's just a characteristic of active record, is sure, you can cast some things, but you cannot hide persistence details. So if we look at total and minor, I can still access it. And there's no native idiomatic way to tell active record that this is a persistence detail and should not be exposed on the hydrated object. What I can do though is I can also have that richer object being returned by my model. And then it's going to take some discipline from the team and checks to ensure that you're leveraging that. So with Eloquent specifically, I can go here and I can say, for example, I'm going to say total. And this is going to return a money object. And I could call this as a method. I could say, thank you, Copilot. I could say something like this. So if we go here and say total, we get a richer object. That's pretty cool. Nothing stops me from just calling total and minor and just skipping the entire process, right? Or calling currency, I can still do that. So it takes some discipline. Alternatively, I could use custom attributes, which is a feature Eloquent supports. And I could say that this is going to return an Eloquent attribute. And then I could say new attribute. We want to get a value. So we're going to have mixed value. We're going to have an array of attributes. And we can say that we want to return a money object. Thank you, Copilot. I think this will give me the raw currency string. Let's see. Sorry, this is not supposed to be a method. We can call it as a property now. Yes, this will give me the raw currency string. So we could do this currency to get the hydrated object. And now you're getting a proper money object. So I'm actually going to go back to the previous one. If you're using the attribute syntax, the reason this is useful, you might think, why not just use a method if it does the same thing, is that you can also set up setters. So you can tell Eloquent how to set that value. We're not going to use that for now, so I'm going to revert that to a method, just a regular method, and we're going to call it as we were. So on the read side, that's one of the things you can do. You can not use your primitives if they are not sufficient to what you want to express. If you need a more complex object, return a more complex object. That's fine, and you should do it. Now, again, as I said, in real life, projects are much more complex. So try and imagine how you could apply this to, let's say, your day job. What are some places in your code base where you're dealing with primitives and having richer objects would help you express what your domain does in a better way? Okay, not much to see there. So my advice here is try to avoid what you consider persistence details. In our example, I would consider total a minor a persistence detail. I want to return this money object. I don't really care how it's stored in the database. That's detail. In fact, order lines, if we were not using active record, even with active record, you can also do this. This might not even be a different table. This could be a JSON column on your table. And your model doesn't have to necessarily know about that. Of course, with active record by default, each model is a table. So the idiomatic way is to have order line represent a different table. That's fine. But all I'm saying is your domain model does not necessarily need to be a proxy of your table. It could be different. It doesn't have to be the same thing at all. Now, let's look at the right perspective. So I have this controller, and again, very simplified. We create some products. We call this orders route, and we pass. We want 2 of product 1, and we want 1 of product 2. In our controller, and this is what I mean with active record, you can persist objects at any place, at any time, and you can fill any properties you want. This is a very common thing to see in Laravel and Rails applications, for example. You go into a controller, well, I can just create a record here. That's fine. And then I can attach more records to it. I can update the records. We even have a method to recalculate the total. So you're treating that, in this scenario, you're treating your model as a very simple data bag. It's essentially a proxy to your database. What you're saying is create a database record with this data, and then create database records with this data. If it's really simple, that's probably fine. But if you have an application in production, if you have actual customers, if you're growing, if your code base is growing and getting more complex, it's really important to have authoritative representations of the operations your domain affords. So what are we doing here? We're placing an order. So I would actually like to call something place. This is what we're doing. We want to have one definition of what it means to place an order and what it does when it comes to placing an order. So let's try and rewrite this from scratch and see what we end up with. The reason we want to have a concrete definition of what it means to place an order is because you can handle invariants, which are essentially validation within your domain. So ensuring that the operation fails if it's not in a valid state. And because as your application grows, imagine if you have this in 2 places, what's the similarity between them? There's none, because this is just a query builder call. You're just saying insert this into the database. So let's see what we could do here. What if I called a place method that took a user object? If you've ever stumbled upon, for example, domain-driven design resources, you may notice that it's common to pass identifiers, typed identifiers. So you're going to see something like an order ID object and then order ID, or a user ID object and the user ID. I should talk about this in another video, but one of the reasons is a user ID object is only going to be present in a user domain model. There's only one place where it can be instantiated from. So you can pass a reference without having to pass an entire hydrated instance of a model of an entity, while knowing on the type level that it is a user ID. If you were just to pass an integer like this, what stops you from doing this? Nothing. Or what stops you from doing this, right? So just a side note in case you read some resources and you get confused about that. So what if we could place an order to the current user, and then let's say in a given currency and with some items. I already have an items object here that takes an array of items, a currency, and then you can also instantiate from an array. So let's do that. Let's say items from array. The input would be the items themselves and then a currency. So if we look at items, we're collecting the input. So we take a product ID and we take a quantity. We hydrate those into this item object, which is just a pair of product and quantity. So it represents an item that should be included in an order. The benefit of using, and I have another video about this, those objects is that now you've established a contract that your domain model can use. With arrays, you have no guarantees whatsoever. In fact, in production, I would actually include some assertions to make sure that those are present. But this is a quick video. It's already longer than I wanted it to be. So let's not worry about that. So we want to place an order. And honestly, this is not handling payment. So this is what it should do. This is it. So I'm actually going to early return here. If we run a test, obviously going to fail. So let's go ahead and add this method. I want this to be a user instance. This is going to return self. And this is going to be called items. So the first thing is, if we're placing an order, we're going to create an order, right? The reason we have to create this order first is because with Active Record, for you to attach those order lines, you need to have an instance of order first. Since we're doing it within a transaction, that's fine. If an operation fails, the entire thing's going to be reversed. So let's go here and we're going to say, I'm going to do all of this within a transaction. And let me just use user and items. We're going to say that the order is going to be self-make, so instantiate an object. And we're going to be very explicit here in the sense that this object is going to be in a state that tells us it's not ready to be paid for. So let's copy what we had here. I'm just going to copy this for now. There we go. Okay. Obviously, we have the user, so you can say user get key. We have the currency. And total miner is going to be 0 because we don't have any line items to this order yet. And the status empty, not the best word, but it just means that the order is not ready to be even paid for yet. Now that we have the order, we're going to add the items. So we can say that for each one of the items, we want to add order line. And we're going to, okay, it doesn't allow me to create this method. Do we need to add a doc block here? No. Okay. Anyway, so we want to add an order line. It's going to be a product with a given quantity. So let's put it here. It's going to be a private function. So we're going to say add line item. We're going to take a product. We're going to take a quantity, and we're not going to return anything. So now let's copy what we had here. Obviously, we're in an object context. So we can say we want to save a new order line. The total in miner is going to be the product's price times the quantity times 100 to move to cents. Obviously, if you're dealing with multi-currency, that's a little bit more complicated, and you would have to pass that to your money object probably. So you would actually want to receive a money object here maybe, but this is an example. And quantity. So we're calling this here. Once we've added the order lines, what else are we doing? We're setting the status. So we say that the order is pending. It's ready to be paid for example. And we could also recalculate the total here. So we already have this as a method. Something that you have to be aware with Active Record especially is sometimes you have lots of operations that persist something in a database. So we have one insert and then one insert for each item. With non-active record implementations, it's common for you to update everything in memory. And then at the end of the process, you persist everything all at once. So you delay persistence until the end of your operation. Okay, now we can set the status to pending. And we can save this and we can return order. Let's see if this works. No, it doesn't. Call to undefined method, add order line. Oh, it's add line item. Sorry about that. So add line item. There we go. So it's working. And you may think, okay, you've just extracted that to a method. But there are a couple of important things here. So let me just get rid of this and we're going to go through them. We don't need this transaction. In fact, what I would do is in real life, I would probably have a command for this, an action, for example, and I would run that within a transaction. So you don't necessarily have to run this. You don't have to lick this in here. What's important here is, first thing, we gave this a name. We gave this operation a name. So it's represented within our system. There's a place. There's a place within your system, within your order model that defines how to place an order. That's a representation of the operation. You have a single source of truth. Secondly, you can properly handle state internally here. So since we've encapsulated this in this place method, this is the only place in your model that allows us to transition an order to a pending state. In fact, it's the only place where we can persist in your order in your database. Okay, Mateus, but what stops you from just going here and saying order create or doing this in another place? Nothing stops you. And that's why I say that with active record, you need some discipline. So if your system, and this is going to vary from business to business, from software to software, but let's say that you're on your e-commerce application, the only way that a user can get an order in the system is by placing an order, then this makes sense. The only entry point for that is going to be through this place method. If your system supports multiple ways to place an order, maybe a user can place it, maybe instead an operator can do it from the backend, even though it would be pretty much the same implementation. But if you have different ways of getting that initial order in, then you can define those as separate methods, as different operations. And within our order model, as I said, we've coupled this state transition to the place operation. What if I wanted to pay for this order? Well, let's say that I wanted to do something like this. I would say pay. We would take, for example, a payment gateway abstraction, and this would return a payment. What I would probably do here is I would first check if this order can be paid. So if this order is not pending, and then this pending would be a Boolean, would say status, order status, pending. I would throw an exception. I would say order could not be paid for because it is not pending, right? Something like this. And then obviously we would have to create this exception. I'm not going to do it for the video. So this is an invariant. Since pay is going to be our single source of truth, our entry point to this, our definition of this operation, we can say that if an order isn't pending, then it cannot be paid for. This is a business rule. This isn't just some code concern. It's how the business wants to operate. You can only pay for orders that are pending. If the order has been paid for, or if it's being refunded, or if it's being shipped, it cannot be paid for. If it's empty, it can also not be paid for because you don't have line items. So that's the first thing I would do. And then you could do something like, you could try paying for this. So you could say payment gateway, charge. That's great with Pilot. It just doesn't exist, but okay, this is great. So let's say something like this. We want to charge something. We want to catch an exception. Okay, that's actually pretty great. So we want to say if the payment failed for some reason, we want to throw an order could not be paid for. You might ask, okay, why catch this exception? Just to throw another exception. And the reason is context. This exception refers specifically about orders. This one refers specifically about payments. In fact, we would also probably record a failure here. So we could say record failed payment and do something like, I don't know, failure message or something that our exception exposes. So we could record a failed payment and then throw this exception saying that the order cannot be paid for. So we could show something to the client or something like that. Otherwise, if the payment went through, we would say payment, and then we could do something like record payment succeeded and pass a payment, right? And then, I don't know, we could return the payment. So we're also coupling a bunch of state change to another operation, which is a payment gateway. You might think, okay, this is insane. Why would you pass an object to a method within your model? I think this sometimes can be great because now you're coupling the act of changing state within an order to say that it's been paid for to the operation that actually pays for it. So there's no chance that this method is going to be invoked without a valid payment gateway and without a valid payment. A pattern that I see often people do is something like, you have this pay method and all it does is change the status. This is fine. If you're disciplined, this is completely fine. You can have your command, your action where you actually do the payment against Stripe or Braintree or whatever, and then you call this. But this does not protect you from just calling pay, right? Nothing stops you from calling pay. And with software, as it grows, you definitely want guardrails. You want to minimize the chances of doing something by mistake. And this is a great pattern to allow for that. In this case, again, content for another video, payment gateway wouldn't necessarily be a generic payment gateway implementation. It would probably be something tailored for this order context that would then leverage those more generic abstractions. This is also super easy to test, assuming the payment gateway is an interface. If you want to test this without hitting strike, for example, you can just pass any memory gateway. I have another video talking about this. Okay, cool. So we essentially have some things here. We would obviously probably also change the status to say that the order has been paid for, and whatever else we want to do. We would probably attach a payment ID or something like that, which could go here as well. So you see how doing this, and in your controller, you'd say order. Maybe this is a single operation, right? Maybe in your command, you do both things. And you could inject it here to payment gateway. So you resolve this from the container. You pass that to the order. Obviously, you would also need a token, but again, just an example. The good thing here is we're giving names to the operations our systems do. What we had previously was just a bunch of procedural code, right? It doesn't have a definition. It doesn't have a name. You don't know what it does unless you scan it. And you can have it in multiple places and it starts to get confusing. But now we've given it a name and we've put it in some place, which is within our model. This is our authoritative representation of the operation. And then within the method, we're handling invariants. So we can ensure this will not happen unless the order is ready for it, unless it is in a valid state. And thirdly, in this example specifically, we've coupled the state change to an operation, which is actually paying for the order. So there is no chance of you being able to copy, have a state change happen without having an actual payment. Again, nothing stops you from just having an Eloquent model, an Eloquent instance, and updating the properties by yourself. But that's why you have to be disciplined if you want to go with this approach and not do it. And then again, we have a single place within our model, just one, not two, not three, not spread throughout the application. We have one place that transitions the status of an order to paid. So you don't have to worry about, this is super common in any application, have an invalid state. You have an order without payment that's paid, or you have an order with a payment that's in a pending status, this sort of thing. The reason is usually one of those. You either have sort of too many cooks in the kitchen. You have things that were supposed to be different models in a single one, and you have a bunch of methods that sort of do the same thing. Or you have those random instances throughout your application that are just being updated ad hoc without concern for failures, data duplication, invariants, that sort of thing. With this, you sort of solve the problem to some extent. As I mentioned, one of the characteristics of Active Record is many operations that could be in-memory updates to an entity to be later persisted happen ad hoc, so you have to be careful about that. But you have an authoritative representation of your operation, which is paying for an order, and it exists on your model. It has a name, it has invariants, it has validation. It's coupled to the operation of actually paying for it, and you don't have to worry about, there's no chance that this is going to be executed and a pending order is going to go through, or that a failed payment is going to go through, etc., etc., etc. So it might seem like a small change, but this is vastly different from what we had, even though the internal implementation is the same. Especially as an application grows, you definitely want to have, and I'm going to insist on the term, authoritative representations of your operations. You want them to exist and be documented at some place. And this is a way to do it. Now, obviously, with most things, this is not the only way to do it, nor is it the only right way to do it. This is simply one way to do it, one that I like. I particularly enjoy fat models, which does not mean generic models. A common complaint, a common concern that I see with this approach is, okay, what if your models will get too big? You're going to have a lot of methods, a lot of relationships. That's not a problem with the model being fat, with the model having a lot of behavior. That's a problem with the model being too generic. You solve that with contextual models, having different models for each context that have far less behavior, far less data, and so on and so forth. Again, fat models, behaviorful models are not the only way. There's a school of thought that prefers data packs that are passed around to actions or commands or use cases, and then the logic is in those use cases. Those are valid choices, but really all that I showed here is also valid to those use cases. You want to have authoritative representations in those use cases. You want to have a single source of truth for each operation in a given context. So really, all that we talked about here on the right side is also valid if you have data bags, if you want to have data bags, if that's your preferred approach. So I hope you guys enjoyed this video and let me know what you want to watch next. I'll see you guys soon. Bye-bye.